So the problem that was given to me is that a triangular trough is 3.6 meters long, 1.2 meters deep, and 0.9 meters wide at the top. It is being filled with water at the rate of 2 cubic meters per second. So the question is that how fast is the water level rising when it is at 0.6 meters deep? So before we start solving, it is important for us to know that what our topic is. So a trough, guys, is a long narrow container for animals to eat. So you know that container that people put like food for the animals and that stuff. So let's get to the solving. So the our given is that the the length is equal to 3.6 meters. So 3.6 meters, and the width is equals to 0.9 meter, and height is 1.2 meter. So and before we solve this, we need to sketch it first. So a trough is like this. It is triangular as it is described in the problem, like that. So this is the length, which is 3.6 meter, the height, which is 1.2 meter, and the width, which is 0.9 meter. So it is stated that it is being filled with water at the rate of 2 cubic meters per second. So we're gonna use this to solve the volume. So dV for the volume and d with regards to time. So 2 cubic meters per second. So 2 meters cube per second, and this will be used as the formula to solve the volume later. So the general formula in getting the volume of a three-dimensional figure is V equals base area multiplied by the length. And the formula for the area of a triangle is 1/2. So that is the standard, guys. So 1/2 weight multiplied by height multiplied by the length. So in order for us to simplify this problem, we can just substitute weight into height, since we are looking for the height, guys, because the height is, when the water rises, it does not regard on the length or the width. It is regarding according to the height. So we are looking for the height. So we will substitute the weight into the height. So we will divide height by weight. So divide 1.2 meter divided by 0.9 meter, and that will give us 1.33 meter. So that's the height, and so that now gives us we will just substitute that. So 1/2, and the weight is, which is now 1 1.33 h, because we substitute weight to height, and h multiplied by length. So let's substitute this, and that will now give us 1/2 multiplied by 1.33 h times 1.2 h and multiplied by 3.6. So after that, that will give us the volume, which is 2.8728 height squared because it had 2 h. So after solving 2.872 h squared, so you just multiply that, and that it will be 5.7456 dH dt. So in order for dH dt, so to transfer, we need to find a way to cancel this out. So we will divide it by 5.7456 and cancel, but also we need to divide this. So 5.7456. So now that is dH dt equals the dV dt. Lately we had that, which is the given dV dt equals 2 meter cube per second, or simply put that 8 meters per second divided by 5.7456. So we will solve that, and that will give us dH dt equals 0.8354 meters per second. So that's it, guys. The